Hello and welcome back to the channel. Unless you're new, then welcome. The following is a podcast with Yashraj Gaikwad. He is a student from AIDS branch from my college. And over the past 3 to 4 years, he has worked with some really good projects. We talk about projects which he has worked on, such as the sine wave simulator.
ये आप मेरे गिटहब पर देख सकते हैं और जब मैं स्पेस बार प्रेस करूँगा ये मेन एप्लीकेशन सेटिंग्स इसमें हम रजिस्टर कर सकते हैं यूज़र को फर्स्ट नेम
And he's a student of AstroMediComp, a topic which we talk in much detail. And more things like gaming and the technology used behind game development. Yashraj has studied the topic of multi-OS systems in much detail, such as Linux, Windows, and other low-level kernel things, and the inception of UNIX. So sit back and enjoy. What inspired you to pursue a career in technology, and how did you get started in the industry?
So during my school days I studied first Java programming language. We both were in the same school.
Yes, we
So
know.
after that I was really keen about technology. I used to
Hmm.
play games as my hobbies.
Hmm.
Then I wanted to delve deeper into it, like how games were made, how computers work, and the internals of it. So
Hmm.
it got me closer to doing software engineering, and I
Hmm.
also liked science, so I pursued it in 11th and 12th.
Hmm.
So after coming to engineering, I got to know about computers, basic C++ programming, hardware, software,
Hmm.
like that.
Okay. So both of us have a passion for playing computer games, but
Yes.
personally, I have never considered being a game developer. But have you ever considered on your own side to become a professional game developer? And we have also talked about the Indian market because it's not up to date for the game industry. Other countries can make AAA games very good. So what do you think about it?
Yes, game development is a very good topic to discuss.
Hmm.
So how game works internals. It is also low-level programming. It requires
Hmm.
C and C++ and
Yes.
graphics libraries such as OpenGL, Vulkan, DirectX. So and game development has been since 2000s. Like first Doom came out when by John Carmack, first 3D game, and many other Wolfenstein 3D like
Hmm.
that.
Hmm.
So in the early days of technology, India was not a big player in. But now I think India can be a great leader in game development and also in AI. Like
I
that,
think
India is a
yes, I think India is more set for mobile games, but not for computer games. What do you think about it?
yes, that is true. We have high population playing mobile games such as
Hmm.
like PUBG,
Yes.
all that is very popular in India.
Hmm.
So we can focus more on mobile gaming
Hmm.
instead of PC gaming because mobile can be afforded by anyone
Hmm.
to run and play games and enjoy
Yes.
together, like compared to
Uh,
PC.
okay. Did you ever consider becoming a game developer yourself, or sometimes someday in the future you might like to pursue that field?
Yes, I've studied about game development. Game development can be done in various methods, like through game engines or without using a game engines. If
Hmm.
we consider doing game engines, there are multiple game engines like Unreal, Unity, Godot. So Unreal is mostly used for 3D, and it is not only used for game development, but is also used in movies and VFX.
Hmm.
Example, Mandalorian a series, it heavily used Unreal for its background scenes. Also now many movies use it.
Oh,
So
okay.
it is very popular, and Unity has been also very popular. It is mostly used for 2D games, can
Hmm.
also be done in 3D. Recently, Unity faced a backlash because of its developer fees.
Hmm.
And then Godot is open source game engine. It is also good for 2D and 3D, mostly for 2D, like that. And also other game engine include a Coco game engine, like that.
Is
And
Blender a game engine or is it used for something else?
Blender is a 3D software, free and open source. It is mostly used for making 3D models, modeling, animation, sculpturing, rendering. So we can make all the models, for example, trees, cars, a man, woman in Blender and then import it in our game engine
Hmm.
like that.
What size teams does it require to make such games? For example, if I'm playing Valorant, how many people does it take to build such a game? Does it require large teams, or can a person like you and me build it realistically in 2 to 5 years or something like that? Forget Valorant. What about campaign games? What do you think?
Okay, so first about Valorant, I think it is a 3D game, so
Hmm.
it would require many people, team size. It can also be developed in indie, but it has many functionalities because it is a network game, so
Hmm.
it requires servers to build. So you will need initial funding to have your own servers and for the networking purpose to have online multiplayer games with each other. Also, considering Valorant, you want to make a map, for example, you can make that in Blender. All the 3D software and assets can be made in Blender, and they're also available for free open source. You can import them taking the license. After that, character models are also available, and then you can code in Unreal Engine, basically multiple characters, and it will require also networking testing, server and client side, and
Uh,
performance improvements.
which programming language is used for this?
Unreal uses C++, and Unity uses C Sharp,
Okay.
and the other is
Yes. So is it easy or is it really difficult for someone to learn? Someone like us, that is.
so game programming is very easy. First,
Hmm.
you can play the games to understand how it works.
Hmm.
After that, you can use basic software like Scratch, or there are basic tutorials available for Unreal Unity,
Hmm.
which are how to make your own game, personal game, Hello World in game,
Hmm.
like that. So it
Okay.
can easily be done. So also the second method of game development is without using any game engine, making a game from scratch. It is
Hmm.
like making your own game engine, which can be done in
Hmm.
OpenGL, which works on multiple operating systems. Then DirectX specifically works on Windows, and Vulkan, which is also latest version, new version of OpenGL. It also open source, can work on any platform.
Hmm.
And Metal, which works on Apple devices, macOS, iOS, like that.
Okay. Okay.
Also
That's
VR AR is upcoming field in
Hmm.
game development.
Do you personally see any future scope in AR VR? Because virtual reality requires a lot of investment, and we are not seeing much progress in it. At least from the perspective of gaming, it's fine, but most people use AR for other applications like healthcare or logistics in companies. But for gaming, do you think it has a purpose for consumers like us who do not have to pay top dollar for it?
Yes, AR can be also used for game development. We all played that AR game in 2016, which became popular, which was
Hmm.
based on a TV series. Can you
Yes.
guess?
TV series? No, I cannot
Uh,
guess.
Cartoon. It is a cartoon. It became a game. Then everyone was playing. Uh, they were
Pokemon. Pokemon.
yes, Pokemon Go.
Yeah, yeah,
Pokemon
yeah, I
Go.
know. Pokemon
Uh,
VR.
It, it
Yes, yes.
uses that AR for showing that
Uh,
characters. And then we throw the ball like that.
hmm, hmm,
So Apple also has many AR apps it
hmm,
uses. And AR VR is not only used for gaming, but it can be also used for industries to train people, professionals. For
hmm,
example, in medical, in military, it is used for training sessions. Like that, there are also many companies which provide services training of VR and AR. It is a specialized field, of course, and it has a costly equipment
hmm.
to make. And also, it works for only 1 hour or 2 hour. It has low battery life, and
Hmm.
it can affect our eyes if we have some problem about it.
Now,
And we
I think most companies prefer to gamify that approach of AR VR because recently I attended a session at Tech Expo in COEP, and there was one company in their stalls which had the VR equipment, and I tried that VR equipment with the headset. It was comfortable, and their application was education. They were orienting it for syllabus summaries and all, and they were collecting feedback from us. But when I wore that VR, all I could play with were the picking up objects or throwing balls or shooting guns. That's all it had. It had nothing to do with education. So, do you think in future there could be a unification between gaming and education, something like that?
Yes, I think you went to the wrong stall because I went in
Okay, okay.
PVG when we had that tech startup
Ah,
session about there are multiple companies came. Then there was a VR stall
hmm,
about it. Then it showed about a car. There was a car
hmm,
engine, and we have to click on each component, and it explains how does it work, and we
hmm,
have to fix that car. For example, there is a mechanic. Then he grabs a tool from one place to another, and it shows how the process. First, we have to change the oil
hmm,
like
hmm.
that. And we have to turn like that. And then
So
later,
it's
I went to college,
yes, so it's really good
science.
for mechanical and electronics engineers, especially.
It can be used anywhere,
Hmm, hmm,
uh, regardless of that, I think. Because it can also be used in medical or engineering, anywhere
hmm,
where it requires interaction between machinery or components like that. If to take it is very difficult to take it physically. For example, in military, you want to build an aircraft or build an engine. It is
hmm.
hard for each person to have its own component and study. So we can virtualize it. So it is easily accessible to everyone in any place without having the physical components with us.
Okay, okay, got it. You are a student of AstroMediComp, and that was something important which really stuck with me. So, could you explain to us what exactly is AstroMediComp?
Okay, so AstroMediComp is a name given by our students to our research institute or class.
Hmm,
He is Dr. Vijay Gokhale, and he's been teaching medical and computer science since 30 years. So first he used to teach medical batches, then he started computer science,
hmm,
and he also knows about astronomy and astrology and
hmm,
studied them. And while explaining computer concepts, he used
hmm,
analogy from different fields, from medical, from Bhagavad Gita, from Mahabharata, from interstellar, like that, and teaches it using examples and analogies, so helps us to understand the concept easily.
hmm,
So first, I will start with the seminars.
hmm,
So very first is the fundamental seminar. It is morally compulsible, compulsory for each student to do. and mostly it is done first by all the students. So it is a 2 day seminar, happens mostly on Saturday, Sunday, and mostly 10 in the morning to 10 at night on both days. So I think 15 plus hours sir teaches continuously with 1 hour break in between for lunch, dinner, coffee,
Hmm.
like that. So
Okay.
in fundamental seminar, it starts from basic, like from any person from any background can do it and
Hmm.
attain knowledge about computer fundamentals. So sir teaches how does from where 8 bits come, like 1 byte is equal to 8 bits. So from where does 8 come? From where does decimal binary number system comes, and another number system like octal, hexadecimal,
Hmm.
binary, and how they are related to each other.
Okay.
How did the computers began?
Hmm.
It is mostly taken from the book How Computers Work by Charles Petzold, like
Hmm.
that.
Hmm.
Uh, so for 1 bit, it has two values, one or zero, one
Hmm.
or on or off, like that. So if you want to communicate between two people, for example, I'm here and my friend is in the next building,
Hmm.
and we don't have phones to communicate with each other. We only have light bulbs. So we can have a Morse code,
Morse
like
code,
on
yes.
off, on off, on off,
Okay.
like that,
Hmm.
and we can communicate through
Hmm.
that.
Hmm.
That same concept was taken in computers, where there are 8 wires at first,
Hmm.
and the first bit has value 2 raised to 0, then
Hmm.
second bit has 2 raised to 1, then 2 raised to 2, like that.
Okay.
So we can represent digits like 0 in decimal is 0, in binary 1 in decimal
Hmm.
is 1, and 2 in decimal is 1 0, like that.
Hmm.
Continue.
So
So
that was the fundamental seminar. So you mentioned that there were other more important seminars. So could you then tell us what exactly you
uh,
did after that? So okay, before we move on, sorry to interrupt. I think that this fundamental seminar was really important and it should be taken up as course for by each and every one of us studying computer engineering, or in your case AIDS branch, because back in first or second year of engineering, we also had some similar topics like what is a bit and how to represent digital information, but those were just boring syllabus things. They couldn't explain it using interesting analogies like you mentioned. And
yes.
do you think that this course should be something done by every student when it comes to learning about fundamentals in computer science?
Yes, I think not only by every student of computer science, each individual who is interested in technology or
Hmm.
knowing about things of science should do fundamentals course, because
Hmm.
there are mostly 200 plus students, which includes like 7th year standard to 50 plus year experienced people. So even people in companies should do and go back and study fundamentals to get
Hmm.
a better grasp of things and understanding how they work in physical real life,
Okay,
like that.
okay.
Then later in fundamentals, we also discussed multiple Intel CPU series, AMD CPU series, like that, which is
Hmm.
very interesting. Uh,
You
then
guys
second,
started from the very first CPU, right? The 885
yes,
Intel, and
yes,
then the latest ninth generation, I think you mentioned.
yes. Wait
Okay,
1 second.
so how was that journey for you? Was it interesting learning about all the
Yes.
CPUs? Okay, okay. So then moving on after the fundamental seminar, what other seminars did you do under AstroMediComp?
So second seminar is multi-OS seminar. It is about
Hmm,
how to install 10 plus operating system on one PC.
hmm,
Uh, which can, for example, how to install multiple versions of Windows through UEFI boot, which
hmm.
is UEFI stands for Universal Embedded Firmware Interface.
Okay, okay.
Universal Firmware Interface, like that.
Hmm,
So our sir used to say that never use a short form without knowing its full form.
hmm,
Like
hmm,
most of us use short forms without using like full forms,
okay.
like that. So in multi-OS, for example, if you want to install multiple versions of Windows, like Windows XP, Windows 7, Windows 8,
Hmm,
Windows 10 on one PC, how would you do it? Like
hmm,
that, multiple steps. And also how to install multiple Linux distros, for example, Ubuntu, Red Hat, another Fedora,
hmm,
like that, Arch Linux,
okay.
Pop OS, like that. There are multiple websites which show the Linux distro ranking. By day and day, there are multiple Linux distros, like that. Also, our
Okay.
sir has Unix installed on his laptop,
Hmm,
and he is regarded as the only individual in India who has Linux Unix on laptop, like
that's
that.
great. So tell us a bit more about Unix.
Uh, so I will tell you later in courses section.
Oh, okay, okay, sure, sure. So multi-OS, then after learning about installing Linux distros, what else did you learn? Are there others?
Also about how to install Mac OS on non-Apple hardware. For example, on normal laptops, HP laptop or Dell laptop, they come pre-installed Windows. How can we install Mac OS on that? So it is called as Hackintosh, like that.
Hmm, hmm.
Uh, and also how to install Windows on Apple devices, like how to install Windows on MacBook and Linux on MacBook, like that. Uh,
MacBooks or any other Apple product, they are guarded by security, right? So you cannot install external things on it. So how exactly? You said Hackintosh, is that correct? Did
Yes.
I? So, how does that exactly work? Do you bypass their security or something?
Uh, Apple does not allow to do it, but it can
Yes.
only for educational purposes. So that is
Oh,
called as hacking tosh. So we are hacking into the system like that.
that sounds great. That sounds really great.
Mm.
So, okay. So moving on. You said that you have worked with CUDA. So, what exactly can you tell us about your CUDA projects?
So the third seminar was HPP seminar, which is heterogeneous parallel programming
Hmm.
on CUDA and OpenCL. You
Hmm.
know that our latest technologies, AI, ML, big data, they all work on
Yes.
GPUs. And
Yes.
beside that, the TensorFlow libraries, PyTorch libraries, they all
Hmm.
require CUDA for NVIDIA GPU to run. So
Hmm.
CUDA stands for Compute Unified Device Architecture,
Hmm.
and OpenCL stands for Open Computing Library or Open Computing Language.
Hmm.
So whenever our basic normal program works, it works on CPU. It works sequentially and serially. So CUDA uses, so our CPU has a few cores, for example, 2 cores, 4 cores, 8 cores, 16 cores.
Yes.
But our GPU on the contrast has many cores, hundreds of cores or thousands of cores.
Hmm.
So we run our program on these cores, which work parallelly. For
Hmm.
example, parallel execution gives more performance than serial execution.
Hmm.
For example, there is an image and we want to desaturate that image. So serially, it works by going from one pixel at a time, or even if you do multi-threading on CPU, it takes multiple pixels at a time.
Hmm.
But using CUDA or OpenCL on GPUs on thousands of cores, each core can work on a particular pixel, and you get the results of like 24 hours on CPU versus 24 seconds on GPU. That is why GPU is highly powerful serially, parallelly compared to CPUs.
And this technique works only for NVIDIA GPUs. Is that correct?
So CUDA is a library which only supports on NVIDIA because it's
Hmm.
proprietary. It is closed source, not open.
Hmm.
So it only works on CUDA NVIDIA GPUs,
Okay.
which can be installed on Windows, Linux, Mac OS,
Hmm. Hmm.
PC, and also cloud GPUs. So the second, OpenCL. OpenCL can work on any GPU. It can
Hmm.
work on Intel GPU, AMD GPU, NVIDIA GPU. It can
Hmm.
also work on our phones, and it can also
Oh,
work on web like that.
okay. Okay. That's
So
great.
it is open source. It is made by AMD, Intel, and Apple, which came together and made OpenCL
Hmm.
like that.
Uh, you have used both of them. Am I right? OpenCL and CUDA.
Yes, I have used them on Windows and Linux.
So, out of the two of those, which one is better in your opinion?
Uh, Both have their own pros and cons. For example, if you have NVIDIA GPU, then CUDA is best for you
Hmm.
because CUDA is perfectly made for that GPU.
Hmm.
Because OpenCL has to support many hardwares, many operating system, many languages.
Hmm.
It has a more overhead
Okay.
compared to
Okay.
CUDA.
Got it.
Like
Got
that.
it. So,
But if you don't have an NVIDIA GPU, then OpenCL is your best option.
okay, got it. Do you think NVIDIA has done right in making it proprietary instead of open source? If you were in the place of NVIDIA, would you have preferred releasing it to the public or keeping it specialized only for your GPUs?
So Nvidia first it began as a graphics company. So it has
Hmm.
its own GPU and it has a monopoly of GPUs.
Hmm.
So if you want a monopoly, you can't open source it. Like also latest OpenAI, but it's actually closed AI like
Yes,
that.
yes. Exactly, exactly. Got it. So heterogeneous parallel programming.
Yes.
What is the meaning of heterogeneous? How does it come into play here?
Okay. So in basic 11, 12 science, there were in chemistry there was like homogeneous substances and heterogeneous substances. Homogeneous means they both are same. For example, liquid, liquid, or solid, solid, like that.
Okay.
Homogeneous in this case means like there are two CPUs, the same CPUs, or two same NVIDIA cards like that.
Hmm. Hmm.
And heterogeneous means two different things. For example, a CPU and GPU. So
Hmm.
whenever you run a CUDA code, the CUDA kernel part of it, kernel in CUDA is a specialized code which works on a GPU. It is also called as shader. So like
Hmm.
that. So CUDA code has two main parts: CPU code and GPU code. GPU code runs on GPU, and CPU code runs on the CPU. So it has two different components. That is why it's called as heterogeneous.
Okay, got it, got it. So now, when it comes to this seminar which you did, would you say that it is beginner friendly? And if it is beginner friendly, would you recommend it to anyone who is looking for pursuing a career in AI? Do you think it's important for anyone interested in AI?
Yes, for example, two main parts. If you're interested in AI but you're only using Python, you
Hmm.
should know the underlying hardware. How does it really work behind the system, behind the cores,
Hmm.
like that. So I recommend it for AI or ML engineers. Also, if you want to optimize your AI ML code, you can, if you are making your own LM model, you're
Hmm.
deploying it, you can go to the CUDA cores and see where you are lacking of performance, and you can fix those issues to increase the performance of your model.
I have not faced any such optimization issue, but I know what you're talking about. When working with some of the projects, like I was going through a PyTorch project, and there is an option, there is a function which you have to call, like device which you have to select. Either it's a CPU or GPU, and for that you make use of a CUDA function. But if you don't use that function, then that process will be very slow. So I think it's really really important. But I work in Python, so I do not have to care about the low level building blocks. The Because CUDA refers to these low level things, and Python I can just build on top of those abstractions. So if I am a Python programmer, do you think I should know the very low level details of how CUDA works, or just a basic knowledge is fine?
So there are like two options. If you know it, it's like better.
Hmm.
As a programmer, you can understand the low level things and improve on visualizing high level concepts.
Hmm.
So yeah, and if you even don't know about it or study about it, in future you may face like one issue about it, and that's it. And if you have that knowledge, it will helpful for that one issue. Else you can ask others for like guidance or support like that.
Okay, got it. So one of the applications of HPP is blockchain. How exactly does it come into play when it comes to blockchain?
So blockchain is a decentralized technology.
Hmm.
It requires it is mostly used for cyber security.
Hmm.
If you want to encrypt data and place hashing algorithms.
Hmm.
So for that encryption and decryption, CUDA can be used to increase its performance parallelly on
Okay.
GPUs like that.
Okay, got it. So the most important power of CUDA is the matrix multiplication process, I think,
Yes.
and GPUs are best for matrix multiplication. Could you tell us more about some things which you know about matrix multiplication?
First, device properties. So I ran this on NVIDIA GeForce RTX
Hmm.
350
Hmm.
laptop GPU. Where you can
Hmm.
see. So first, it shows the number of GPUs in our system. For example,
Hmm.
if you have a PC, we have multiple GPUs, it will show two. It support CUDA. For example, if you have two NVIDIA GPUs, it will show two. Here in my case, it was one. Then it shows CUDA driver version
Hmm.
12.2. So whatever devices on our system we have, there is also device driver which runs that device. It's
Hmm.
called as device driver. So it has its own version, and CUDA runtime version is 12.2. Then device number 0 because it is the first GPU. So all the devices are stored in an array, and an array starts from 0. This is why 0. Then GPU device name, RTX 350 laptop GPU. Then its compute capability, that is
Hmm.
performance, 8.6. And clock rate, that means how much amount of processing it can do in few milliseconds.
I
Same.
think I see here that the total RAM memory is only 4 GB, and for running vision applications it's fine, but you cannot fit LLMs on this. Am I right?
Yes, this is GPU specific memory, which is called as VRAM or
Yes, VRAM.
VRAM, video RAM.
Mm-hmm.
And then total memory can be more like 16 GB
Hmm.
for whole PC like
When
that.
you were running your projects on CUDA, did you face any memory limitation issues?
No, because these are basic programs like device properties or matrix multiplication. It can work on any GPU which supports CUDA,
Okay, got it, got it.
but its performance may vary regarding that GPU power.
Hmm. Okay, got it. So
Hmm.
yeah, so about Unix, can you tell us more? Okay, so before that, let me ask you. One of the posts that I was impressed with on your LinkedIn was that you read a new book called, I think, sorry, new no, it's an old book, The Magic Garden Explained, Internals of Unix System and Open Systems designed by Bernie Goodhart.
Okay. So starting from course of AstroMediComp, Unix is a course, like it is about operating system, and it's been running since 20 plus years, and there have been 200 plus students each year. So this is the first book, the design of the Unix operating system.
Hmm.
Is it visible? Yes.
Ah, yes, it's
So we
visible.
study this book
Hmm.
in this course. It is by Morris J. Bach. It is for the design. If you want to design your own operating system, how does it work? It has
Hmm.
algorithms in it, like file system, process subsystem, like that.
Hmm.
And this is another book, which is a Magic Garden, a
Hmm.
Unix implementation by Bernie Goodhart. So this book was gifted to be my sir for completing Windows development project of sine wave simulator.
Hmm.
So in this book, the author explains as Unix and Linux, they are like a garden. Like there are multiple distros
Hmm.
or flavors of Unix and Linux.
Hmm.
That is why it is
Okay,
described as the
so
Magic Garden because it has a
okay.
powerful force.
What can you tell us about Unix? Why is it important? And how did Linux evolve from Unix?
Okay, so Unix is the mother of all operating system,
Hmm.
and while first so the history of Unix starts in AT&T Bell Labs by
Hmm.
Dennis Ritchie and Ken Thompson.
Hmm.
First, they wanted to make a file manager. That was their assignment by the manager. So while building it, they understand about OS and how can they make a universal OS which works on
Hmm.
multiple hardwares from nail top computer to supercomputer. So that is why Unix can run everywhere, anywhere, and
Hmm.
highly portable. Portable. Earlier, before Unix, there were operating systems which were hardware specific, which can only work on specific hardware. So Unix was developed first on PDP-8, then later PDP-11, and Unix was first written in B language by Ken Thompson. Then later it was rewritten in C language by Dennis Ritchie, like that. So
Who were the
mm,
creators of C or C++?
Dennis Ritchie and Ken Thompson.
Okay, so the same guys who made Unix made C and C++.
Yes,
Okay,
yes.
okay.
C++
They were the
is made
yes.
by John Stostock.
Okay. Ah, yes. So that's the C++ programming language. That's the definitive textbook for that. Am I right?
Yes, C++
Okay, super.
came far later.
And what about Linux? How is it different from Unix, and why is it more famous than Unix?
Okay, because Unix, when it first came, it was not accepted by its company. So they
Hmm.
gave an open source version to
Hmm.
Berkeley University. That is why, yeah, that is why. Then they later made it open source
Okay.
and made more contributions to Unix. For example, the VI command editor, like that,
Hmm.
and BSD sockets. The first sockets for internet connections came through that, like that. Then Linux was made by Linus Torvalds. He first wanted to make a terminal emulator as his college final project,
Hmm.
and he's from University of Helsinki in
Hmm.
Finland. So uh, uh, he connected with a person. One
Hmm.
second.
असू दे नो प्रॉब्लेम नसेल आठवत तर राहू दे स्किप करून घे.
Uh, so he wanted to make a Linux open source.
Hmm.
So Linux is only the core kernel,
Hmm.
and the other features of Linux include GNU, which are made by the GNU organization. So what we see Linux as now, it is GNU Linux and not only Linux.
Okay.
Uh, so because it has open source contribution from many developers around the world, it made it popular.
Which operating system is your most favorite?
That is a very good question, but I have no favorites because I like each operating system equally. They're like
Okay.
uh, so Windows has its own powerful and benefits. Windows is user friendly. Whenever you go to a shopkeeper, you look and see its computer. It's always Windows. It is never
Hmm.
Linux or Mac OS.
Hmm.
So Windows is everywhere around you. It is the most used operating system PC.
Hmm.
And then Linux. So Linux is mostly used by programmers. Linux is programmer friendly. It is not user friendly. So Windows, like that. So Linux can be mostly used in colleges if you go that are on computers because it is open source, like that, or programmer's laptop.
Hmm.
In Mac OS, it is mostly used by artists. If you go to any art shop and look at his computer, it's mostly Mac OS
Hmm.
because artists prefer Mac OS and Apple. Also,
Hmm.
their phones are mostly iPhone compared to Android phones, like that. So each
Okay.
operating system has its own purpose, I think.
Have you heard of Temple OS?
Yes, I've heard of
Yes.
Temple OS.
Can you tell us more about it?
It was made by one guy.
Yes.
What is his
So
name?
it's the only OS that was made by a single guy, apart from Linus Torvalds. Am I right?
Oh, yes, like
Uh,
that.
and it's really weird because the creator was schizophrenic, and Temple OS is optimized only for very small memory usage. Like the main file is 4 megabytes, I think, or yes, 4
Yes.
megabytes. Yeah, it's really fascinating. Do you think
Mm.
in future we could see any such operating system from you, like your own creation or your own contribution?
Yes, I will try to make an operating system mostly by
Uh,
studying LFS, which is a Linux from scratch, making another distro of Linux for a
hmm.
specific purpose or use case. So
Or
Temple
so,
OS.
which specific use case or customization would you add in your OS?
So I can make an OS dedicated for gamers, like highly performance for GPU users, or
Hmm.
an OS which is tailored for LLM applications or AI
Oh,
applications, like that.
oh, that's nice. Do you know Andre Karpathy? He made a video on this. He was talking about LLM OS, where instead of having I/O input from the CPU, which takes the I/O input, the LLM model takes the I/O input as the prompt of the user. And similarly, instead of the RAM for its memory, it had its long context window as its RAM. So you can abstract an OS in the form of a large language model. Do you think there is scope for such an application in the future?
Yes, I think there is scope as LLMs become cheaper and they can run on low devices, low level devices.
Hmm.
That is useful applications of embedding an LLM in an OS, and Microsoft is also trying to do it with Copilot like
Hmm.
that.
Yes,
So
yes.
in future, we will definitely see integration, deeper integration, and personalized integration with the user experience.
Okay, that's nice. So one of the main projects that you have worked with is Win32. Tell us a bit more about Win32 and all the things that you have done with it.
So Win32 was a part of Windows development course. So Win32 is the lowest level library of Microsoft on
Mm-hmm.
Windows. So
Mm-hmm.
first there is OS, then there are system calls of OS, then there is Win32. After that there is MFC, which is C++ based of Win32. Then there is a COM, which stands for Component Object Model. So it is an object model which helps in to make uh, language interpretability. For example, a code written in C or a library made in C can be used by any programming language, by Python, by C Sharp, by Java, like that. So a .NET, which is the topmost layer of Windows, it uses Win32 and COM internally. So .NET applications can run on multiple OS, like
Mm-hmm.
that.
Okay, so you attended a GPU meetup in Pune hosted by Innoplexus. Uh,
Yes.
do you have any useful insights to share with us?
So Innoplexis by Partex is a great AI company which focus on AI and biology.
Mm-hmm.
So it has many use cases for bioinformatics
Hmm.
in AI, like that.
Okay,
For
now
example, DNA, RNA analysis and protein
DNA
synthesis.
analysis. Oh my God, that's
Yes, so
that sounds very
yes.
complex.
Also, Modi now is including India genome projects. So there was a
Huh.
mega genome project around the world. So genome
Okay.
synthesis of our Indians, like that. So it will require huge
Oh,
computing and data centers.
oh, I hadn't heard of this before. That's great to hear. So, okay, that's nice. You have completed a 4-month internship as a software developer intern at Amnex Info Technologies. Tell us
Mm.
your experience with them and all the projects that you did under your internship.
Yes, so MNX Info Technology mostly is a Gujarat-based company, and I work in
Mm-hmm.
their Pune office,
Mm-hmm.
and they are doing a collaboration with Maharashtra government. My
Mm-hmm.
father works in Maharashtra government in agriculture department, so
Mm-hmm.
their MNX agriculture department and our government's agriculture department had a tie-up to make multiple projects about Maharashtra. They had to make dashboards, for example, for the managers, like uh, the crop output of each area, each field, and the rainfall, temperature, precipitation in each
Mm-hmm.
area, and how it affects and how to sell crops, how the farmers can maximize their potential of crops using IoT uh,
Mm-hmm.
sensors in the farmlands, and taking data from the center sensors and visualizing it into graphs.
Okay.
So which is useful for government, like that.
So, what did you exactly work on under those projects?
1 second.
Hmm. What projects did you work on under this internship?
So at Amnex, I worked on mostly Python-based projects.
Hmm.
In Python, there is a dash board library to make your own dashboards on web. So I utilized it for making interactive dashboard like bar, bar graphs, pie chart, multiple charts to visualize the data, agriculture data.
Mm-hmm.
Then later I used Python for scripting. Like there was multiple APIs which I made documentation using Postman, applying multiple requests, get, send, post. Is the API working? And
Mm-hmm.
automating that API for a particular request after every day, and logging the output in a particular file, and then sending it to the user and the client by analyzing the data of the API.
Okay, that's nice. So, the interaction that I had when it comes to GPUs is purely on the basis of the syllabus that we have learned is that we had a computer graphics course, and under that we had a lot of stuff to learn, like how pixels work and how graphics exactly work and how they are rendered using GPU. So have you ever encountered such a project in your 3 to 4 years of study?
Yes, now this is the third course I'm doing, which is RTR, which stands for real time rendering. In
Hmm.
this, we study OpenGL. OpenGL stands for Open Graphics Library, and
Hmm.
it came from IrisGL, which was closed source. OpenGL is open source; it can work on any device, like that. So on Iris X. So first, for Jurassic Park movie, have you seen it?
Yes, I
In
have
that,
seen it.
Steven Spielberg used this IrisGL to make that dinosaur animation
Hmm.
on
Hmm.
computer, and later, which was used by Iris Corp Silicon Graphics, which
Hmm.
later made open source version called OpenGL,
Hmm.
like that. And for the dinosaur to render, it had thousands of PCs running Unix and IrisGL,
Oh my
like that.
God.
There is also documentary on how it was made on YouTube. You can watch it. And there is
Okay.
also a documentary of Triumph of Nerds about Bill Gates and Steve Jobs. and how they made Windows and Mac OS, like that, stealing from each
Okay.
other.
Speaking of movies, in the Irishman movie, Robert De Niro and Al
Yes.
Pacino and other such great old-time actors, they had their face de-aged by
Yes.
using AI and computer graphics. So, do you know how exactly it was done? Can you tell us
Uh,
a bit about
so for that movie, they have a mixture of both prosthetics, makeup, and
it?
AI
Hmm.
using that. Uh, so AI can be used has a many application in movies. For
Hmm.
example, here it was used for de-aging of the actors. Mm. So, from an artistic point of the director, he wanted to show like the young version, or
Hmm.
they wanted to hide the
Hmm.
scars and the wrinkles of the actors. That is why he
Yes.
did it
Yes.
like that.
Now let's move on to use of GPUs in gaming. The very
Mm.
best application that we know of is ray tracing. Modern
Yeah.
games like Call of Duty, Modern Warfare, or Cyberpunk, they make use of this ray tracing technology. So can you tell us a bit more about it?
So yes, ray tracing is a great technology. It enables us to view realistic effects. So our aim in computer graphics is to go near to realism as much as possible. And if you want to go towards realism, you need high computing power. That is why games have demanding computing capabilities. Like you require high GPUs, high CPUs, high memory to run games because they are realistic in nature. So ray tracing works on the basis of light principle and how light is reflected and reflected from objects in the particular scene. So in scene, particular scene, that can be many light sources. For example, sun as a global illumination, and other street lights or car lights, and how they reflect from each surface. For example, in mostly game trailers, there is water is shown on the streets to
Mm-hmm.
show like realistic rain is shown. So how does light interacts with multiple substance? So if light is bouncing on a red ball, it should also emit a red glow towards to it, like that.
Mm.
So it can
Okay.
also be seen in nature, natural phenomenon. And
Mm.
even evenings or mornings, if you look at the sky, there are rays coming out in clouds. They are called as God rays. This is a natural
Mm.
phenomenon, and we also try to implement that in games, uh, like that.
Okay. Uh, Being someone who has played a lot of games, what do you think are current limitations of these modern games, and how can aspiring game developers fix those issues and innovate in this field?
Mm. So I think for Indian game developers, indie game developers, we should more focus on mobile games or particular specialized genre of games. For example, recently the success of Black Myth Wukong in China outsold all PS5 and become the highest grossing game of China in history. Like
Hmm.
that, so India can replicate its success of
Hmm.
being a leader in game industry by using all our mythologies and making games on that, and our stories, old stories, like that.
Now I think that PC gamers have the best advantage when it comes to games because you can just if your motherboard allows it, you can just buy a better version of the NVIDIA or AMD GPU so that you
Mm.
can play such high demanding games. But when it comes to consoles like Xbox or PS5, they don't
Mm.
have that initial advantage, but they
Mm.
still outperform in some aspects. Do you think in future, if NVIDIA innovates a lot when it comes to their GPUs, PC gamers will have a distinct advantage, or do you think that both of them will still be comparable to each other?
I think PC gamers and console gamers have their own pros and cons.
Hmm.
Also, in console, PS5 and Xbox, they are mostly use AMD-based CPUs and GPUs. So
Hmm.
AMD company gets the profit. In case of Windows, you can assemble your own PC requirements, but in PS5, Xbox, you have to buy pre-assembled console. Also, in console wars, PS5 is currently leading the race, and
Hmm.
Xbox
Hmm.
is trying because Xbox games can also work on Windows PC, but
Hmm.
PS5 games are released on PC after 2 or 3 years.
Hmm.
Also, some game developers have their own strategy. For example, GTA 5, it will first come on console, PS5, and Xbox. Then later,
Yes.
after 2 years, it is planning to come on PC. So that they are forcing us to buy the game twice for most
Hmm.
game,
Hmm.
so they can earn money.
Yes, yes. They earn double the money from this
Yes.
strategy. That's nice. Now, seeing as you like both GPUs or programming in CUDA and the Unix aspect, if right now I gave you three options, either you stay here in this timeline, or you travel back in time to the Unix and you become a member of the Unix team to build the first Unix, or you travel back in time and team up with Jensen Huang and build their first GPUs which they used for gaming. Which of these three options would you choose the most?
So the first option is like present, in
Yes,
present.
present. You stay here where you are with all our latest
Yes.
advancements, or you go back in time and become one of the developers in the process.
Mm. So I think Unix is close to my heart. So I would
Okay, okay.
select Unix.
Nice, nice.
Yes.
That's great.
Because I
Uh,
follow Unix philosophy of simplicity and consistency, which is
mhm.
also used in their file system and process system.
Okay,
Mhm.
that's great.
Mhm.
So, for beginners who want to learn more about Unix, which resources would you recommend? Any books or YouTube videos?
Yes, I would recommend first this book, which is
Okay.
yes,
Mhm.
a basic of Unix. So Unix principles, Unix is so generalized. So Unix principle can be used and seen in any OS. For
Mhm.
example, Unix is the mother of our OS. Then you
Mhm.
can say that Unix child is Linux, and Android is Androidized version of Linux. So
Mhm.
basically, Android is a grandchild of Unix, like that. So you can also
Okay.
see Unix principles in Android, and after
Mhm.
that, Android smartwatch. You can also see
Mhm.
their embedded devices.
Mhm.
Mm.
Do you think there is scope for so with the latest progress in AI, most
Mhm.
of the code is getting automated. But do you think there is a lot of future scope for these low-level topics like C++ or kernels, CUDA, Unix? What is your opinion on this?
Uh, So I think that AI, which is used in many companies, it is mostly currently used for support and service roles,
Hmm.
and later it may in future it may also replace developers. But I think there is a less likely chance. For example, whenever we give a task to AI, it does not complete it end to end. It needs reasoning and it needs prompting about it for continuous process of the task. But a human being can do it end to end. So in the case of low level systems like C and C++ have huge amounts of code, and currently AI ML have limited context capabilities about all the code.
Hmm.
Uh, so if you have core knowledge about the system, you can never be replaceable. And I think it is evergreen knowledge which can be applied to many fields.
That's great. That's great.
Mm.
So I think that's it.
Yes.
Thank you for joining our podcast, and yes, it was nice having you.
Yes. So thank you for inviting me. And I also hope that others would study about the fundamentals and low level aspects to get a low level point of view.
Yes, yes, that's great. That's great. So thank you.